All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So you're going to start by removing the 6 by multiplying it by that -4. So you're going to have x squared plus 5x minus 24. And so you're going to end up with 6 plus 6x plus 8, and then 6x minus 3. This first set will divide by 2, and so you'll have 3x plus 4. And then the second set will divide by 3, so you'll have 2x minus 1. So this would be your answer for the factoring. For this next one, we're going to say 8 times 12, which is 96, so we can eliminate a and b. And then when we multiply, we add the exponents. So 8x to the 5th times x to the 5th, you add 5 plus 5, and you end up with x to the 10th. So that would be your answer there. Today we're looking at lesson 89. We're looking at vector decomposition. So hopefully after this lesson you will understand vector decomposition. Whenever you're decomposing a vector, that means that you're separating it into two vectors, which whenever you add them together results in the original vector. When a vector is decomposed, it is split into a horizontal vector and a vertical vector. So one of them is going to have your horizontal component and one of them is going to have your vertical component. The angle of your vector is always given counterclockwise from the positive x-axis. So we've talked about this already this year, and we also talked about it in Algebra 2 last year. Whenever you have your x and y axis, you always start over here and you measure counterclockwise from the positive x-axis. So you're always going this direction. So we want to decompose each vector and then round your answer to the nearest hundredth. So to decompose it, we're going to split it into the horizontal and the vertical components. So this one has a horizontal component of 3, and so you're going to write the vector in the horizontal part, that's your x, is 3, 0. And then the vector that's in the y component, that's the vertical component, is 0, 4. And so those would be your two answers. All right, for part B, we're going to draw it on our coordinate plane. And so it makes a 15-degree angle with the horizontal. That's 15 degrees. And the magnitude is 5. So that means that the hypotenuse length is 5. So we need to find the x component and the y component. So the way that we're going to do that is to use sine and cosine. So if we said the sine of 15 degrees, that's going to be the opposite over the hypotenuse. So y over 5. You're going to multiply both sides by 5. And so these 5s will cancel. And we're going to have y equals 5 sine of 15, which you plug that into your calculator, you should get 1.29. Okay? Now we're going to use the cosine of 15. And the cosine is adjacent over hypotenuse. So we're going to have x over 5. So multiply by 5 on both sides, and when you plug that into your calculator, you should get 4.83. So the vector for the x part is going to be 4.83, 0, and then the vector for the y component is going to be 0, 1.29. So that would be your two vectors there. Okay. Looking at the next example, vector A has a magnitude of 9 and makes a 45-degree angle with the horizontal. Vector B makes a magnitude of 9 and has an angle of 60 degrees with the horizontal. We add them by decomposition, and then we want to find the approximate magnitude and the angle the resultant vector makes with the horizontal to the nearest 10th. So first we have to decompose both of these. So we're going to start by drawing them. So the first one, the angle here is 45, and the magnitude is 9. So to find the x and y, we're going to do sine and cosine. So the cosine of 45 is x over 9. So multiply by 9, and you should get that your x value is 6.36. And then we're going to do the same thing for the y value. We're going to say the sine of 45 is y over 9. So multiply by 9 on both sides. And you get that y equals 6.36 as well. And they should, because this is an isosceles triangle. So now we're going to do the other one. So we're going to draw it. So we have 60 degrees. And then we have x and y. And the magnitude of it is again 9. So we're going to do the cosine of 60. And we're going to have x over 9. And so multiply by 9 on both sides. And so you should get your x value is 4.5. And then we're going to do the sine of 60 is y over 9. Multiply by 9. And you should get that your y value is 7.79. So on these, you need to add your x parts together and you need to add your y parts together. So if we added this x part and this x part, 4.5 plus 6.36, you should get 10.86. That is the x part. And then the y part, if you add the 6.36 and the 7.79, you should get 14.15. And so now that is the sum of the horizontal and vertical components of those two vectors. And so now we need to figure out what magnitude and angle this resultant vector would give. So we draw it again. And our x component and our y component we know. So our x is 10.86 and our y component is 14.15. We need to find the angle here and the hypotenuse, which is our magnitude. So the hypotenuse, we're going to use Pythagorean theorem. So we'll have 10.86 squared plus 14.15 squared. So if you use your calculator to solve that, you should get 17.84, and so that would be your magnitude. And then for the angle, we're going to use tangent of theta equals opposite over adjacent, so 14.15 over 10.86. And so if you plug that into your calculator, you're going to say tangent inverse of 14.15 over 10.86. And so your theta that you should get is about 52.5. Okay? And so that would be the angle that it makes with the horizontal. So this is kind of what we did last year. Whenever we took 9 at 45 degrees and we added 9 at 60 degrees and we added these two together. If you remember doing that last year, that's basically what you did on this example. It's just wording it differently. Okay, so now let's look at example 3. We have vector A, and we have vector B, and we have vector C. We want to add them together by decomposition, and we want to find the magnitude and the angle of the resultant. So we basically have to do what we did on the last one, but now we have 3 of them. So for vector A, we're going to draw it, and our angle is 50 degrees, and our magnitude is 9, and so if you use sine and cosine, your x is going to be 9 cosine of 50, and your y is going to be 9 sine of 50. Okay? And then for your b, we can draw it. Magnitude of 12, and this angle is 20. This is our x and this is our y. The x is going to be 12 cosine of 20, and your y value is going to be 12 sine of 20. Okay? And so if you need to show more work to get those, go ahead. Y'all can pause the video and work it out more. Your vector c is going to have a magnitude of 6. Oh, I didn't draw it correctly. It's horizontal. So that means that it just went this direction. And so its x value is just 6 because it was only horizontal. So to find our new vector, we need to add our x values all together. So you need to add those x values. And then you need to add your 2 y values. And so do that with your calculator. And you should get 17.06. No, I'm sorry, I forgot to add the 6. You should get 23.06 for your x value. And then for your y value, you should get, it's 10.998, so that'd be 11. Okay, and so now we're going to find the magnitude and angle of this new vector. So I'm going to draw it. We need to find the hypotenuse and the angle. We know the x component is 23.06 and the y component is 11. So using Pythagorean theorem, your hypotenuse you should end up with 25.55. That would be your magnitude here. And then the angle, we're going to do tangent of theta equals opposite over adjacent, so 11 over 23.06. So you're going to do tangent inverse of this number, and you should get 25.5 degrees. And so that would be your angle there. Okay? So I don't think that these are necessarily difficult. You work them all pretty much the same way, but they do take a little bit of writing. And so I tried to condense that on that one, but if y'all need to actually work it completely out, that is fine, if that helps you get the right answer. All right, so looking at the next example, we have a tent pole that is placed at 75-degree angle with the ground. So here is my ground, and I've got my pole, and this angle is a 75-degree angle, and it's supporting a load of 22 pounds. So the load here is 22. We want to know what are the vertical and what are the horizontal components of the load on the pole. So that's our horizontal and that's our vertical. So the way that you're going to do that, you're going to use your sine and cosine. And so your x value is going to be 22 cosine of 75. And so that would be 5.69. I think, let me make sure. Yeah, so 5.69 pounds is your horizontal part. For the vertical, that's your y value. You're going to do 22 sine of 75. And so if you plug that in, you should get 21.25 pounds. And so that would be your horizontal part. Your vertical part. Okay? So now let's look at some practice problems. See if you can decompose the vector into its x and y components. And it says round to the nearest hundredth if you're dealing with numbers, or the nearest degree if you're dealing with angles. So we have a vector. and it has an angle of 55 here, and the magnitude, the hypotenuse is 100. So we need to do the x and the y components. So the x part, we would do 100 cosine of 55, and that'll give you 57.36. And then for the y, you would do 100 sine of 55, and so your y value would be 81.92. And so you have 57.36 for your x, your horizontal component, and then 81.92 for your y, or your vertical component. And so that would be the answer there. Okay, let's see if you can try another practice problem. We've got vector P and vector Q. We want to add them together. So we're going to go ahead and draw them. We have a 35-degree angle here. P has a magnitude of 30. And so this is your x and this is your y. And so your x is going to be 30 cosine of 35. And then your y is going to be 30 sine of 35. And then for Q, we'll draw it. It makes a 40-degree angle, and it has a magnitude of 40. And so your x is there and your y is there. Your x is going to be 40 cosine of 40, and your y is going to be 40 sine of 40. And so to find the resultant vector, you're going to add these two x values together, and you're going to add your two y values together. And so if you add those two together, you should get 55.22 for your x. And 42.92 for your y. Okay. Now we need to draw our new vector. And so we have 55.22 and 42.92. And we need to find this angle and the magnitude. So the magnitude, you're going to use Pythagorean theorem. And if you use Pythagorean theorem, you should get 69.93. You're going to say 55.22 squared plus 42.92 squared, and then take the square root of that. And then for our angle, we want to solve it for the nearest degree. So you're going to do tangent of theta is 42.92 over 55.22, and your theta, you should get to be 38 degrees. Okay, so looking at another one, y'all try this one, and then y'all can unpause the video and I'll show you how to work it in case you couldn't get the right answer. Vector T has a magnitude of 12 and a direction of 80. So this is 80 degrees and this is 12. Vector U has a magnitude of 16 and a direction of 0. So that means that it's completely horizontal. Let's go in this direction. So this is 16. And then vector V has a magnitude of 8 and a direction of 64. So this is 64 and this is 8. So we've got our x value and our y value. This is only our x value, and then our x value and our y value. So I'm going to write out what you should get for your x and y's in terms of sine and cosine. Okay, so you should get those. And then to find the magnitude and the angle of the resultant vector, we need to add our x's and our y's together. So if you add your x's and your y's, you should get 21.59 for your x. And then for your y value, you should get 19.01. Okay. From there, you need to draw your new vector. And so our y value is 19.01, our x is 21.59. We're looking for our theta and our hypotenuse, our magnitude. And if you use Pythagorean theorem, your hypotenuse should give you 28.77. And then if you use tangent inverse, you're going to do 19.01 over 21.59, and you should get 41 degrees for your angle. Okay? Looking at one more practice problem. We've got a pole that makes an angle with the ground. That's a terrible triangle. Let's try again. That's a right angle, and this is an 86-degree angle, and the load, the magnitude on it is 25 pounds. It wants to know what are the horizontal and the vertical loads. So the horizontal part is there, and the vertical part is there. So your x is going to be 25 cosine of 86, and your y is going to be 25 sine of 86. So your x value is your horizontal part. It's going to be 1.74 pounds. The y part is your vertical part, and it's going to be 24.94 pounds. And so that would be your vertical and horizontal loads. Okay? So looking at the challenge question. I'll try this one, and then you can unpause the video, and I'll show you the correct answer. The Royal Gorge Bridge that was completed in 1929 is the highest suspension bridge in the world at 1,053 feet. The diameter of the suspension cables is 9 inches. The force along the cable where it hangs from the tower is 1,000 tons. What force is pushing down on the tower, and what force is pulling the tower in towards the center of the gorge? What keeps the tower from toppling into the gorge? Well, we know that this angle here is 65, and so this angle is going to be a 65. We're looking for the height and the base of our triangle. So we can either use this angle here, 65, or we can use this angle here, which is going to be 25. Doesn't matter, you can use either one. If you use the 65, then we're going to say our x, well, I'll work this one out more. If we're going to use the 65, the cosine of 65 is going to be y over 1,000. So our y is going to be 1,000 cosine of 65. And then the sine of 65 is going to be x over 1,000. And so the x would be 1,000 sine of 65. And so if you plug that into your calculator, your y value would be 422.6, and your x value would be 906.3. And so pushing down on the tower would be this 422.6. Pulling the tower in is 906.3 tons. So if you wanted to use the 25, then you could. You would just have slightly different equations set up. So what keeps a tower from toppling into the gorge? The tower doesn't topple because the cables attached from the tower to the ground on the other side, this cable here, is pulling the tower away from the gorge. So this one is pointed in and this one is pointed out, and so they balance each other out, and that's why the tower doesn't topple to the center. Okay, so that's your lesson for today. Your homework is 1 through 30, so you need to make sure that you do that tonight so that we can go over any questions you have tomorrow.